Hi, today's topic is Deeplog, anomaly detection and diagnosis from system logs through deep learning. So, the topic is about anomaly detection. That means detecting abnormality from data. So, input data is system logs. Any system or uh, process can be logged. Any software application can be logged. A system process can be logged in log file as a raw text data. It is a streaming log file. So from that log file, how we can detect the abnormality in the system process. So nowadays the system logs are a huge volume of data are available. So deep learning is coming into the place and processing the raw test data and detecting any type of anomalies from the streaming of live data. So for that they are using deep learning. That paper is mentioned heading as Deeplog. Deeplog is automatically learn log patterns from normal execution and detect the anomalies when log pattern deviate from the model trained from log data under normal execution. That means it is automatically taking. This is an unsupervised method of detecting anomalies. We only need the normal execution files. Only need the normal execution files. No need of labeling. From that file, it will create a model. Deep learning will create a model, and when the live data is coming into the model, any kind of deviation from the normal execution, it will detect as anomalies. That is the detection phase. That is the basic of this paper, how it's working, what it is. And apart from that, this paper is discussing about is doing one more implementation of workflows uh, model. That means if any stream data or log stream is detected as a anomaly or abnormality, it will find, doing a root case analysis, it will find out what type of error, what type of task it was. It is going a diagnosis on top of that anomaly detection. That is also an advantage of the paper. So we are going into the topic, and the first part was introduction. In introduction, what they are telling, in previously there were three type of methods we are using for the unsupervised anomaly detection for these log files. That was one with the PCA based approach, was mentioned in this paper, and invariant mining, and third one is workflow based method. Or method is mostly workflow based method. So this method is overcoming the drawbacks of that two methods. The PC method is just nothing, is it's a dimensionality reduction method, right? From a huge file or huge data, it is reducing the dimension in and representing the input data in a small feature vectors or dimensions. And then when a new test data is coming, it will project that test log file into uh, that original file by using this PCA metric, PCA representation. Then it will analyze a kind of distance or variation from the representation, PCA representation. It will detect as anomalies. But this is these methods under required lot of data, but not that much robust for detecting the anomalies. So here, this paper Deeplog is automatically learning the model. They are using LSTM method. LSTM, they are using the sequence based approach to detect the patterns from the data. So next paragraph they mentioned about the challenges in this paper. The first challenge they are telling, so this data or the original data is unstructured. That means a raw data of text, raw text data. So converting this unstructured data into some structured data, or might be applying on top of that deep learning, is a challenge. Maybe they are telling that. And apart from that, so many rule based algorithms were used before in past years, but there have a lot of issues because that need lot of supervision to detect the pattern. A lot of domain knowledge was required. That was the challenges earlier. So here what we made, and after that deep learning approach came, but that deep learning approach we are using binary classification approach. They need both supervised, both anomaly and normal execution type of files. They need labelings. So that type of deep learning was not effective because the main reason is 99% of your data might be normal execution. Only 1% or less than 1% only you will get the anomaly detection. And second disadvantage of supervised model is that if you are missing any kind of abnormal pattern in your training data, that kind of new pattern of anomalies coming in your test data, you are not able to find out that classification properly because you didn't see it in the training phase, right? So that two kind of disadvantage they were overcoming by using this method. This is completely unsupervised. So next section they're telling about they're telling the same point that they need only small training data set to do the training. That's also one more advantage of this Deeplog paper. And once the problem is diagnosed, they're telling that they will add one workflow model that will diagnose the about the anomaly, and it will come to conclusion how this anomaly is coming. Okay, so the second main preliminary is the telling the log parser. So log parser is the first step of this paper, this project execution. So how that means the input data is unstructured raw test data, right? So to convert it into a structured data is the first challenge, and that is the first requirement. Then only we are able to represent this log stream in terms of sequence. So that is they mentioned in this table 1, the left column log message. See, there are 3 log messages were mentioned. T1 deletion of file 1 complete. Okay, so the underlined section deletion of and then complete. This underlined structure, that kind of particular log is they are mentioning as log key K1. So that is the first step, that we need to extract this type of log key underlined. The underlined log key words, that kind of pattern is named as template. If any kind of this message is coming in your log file, that will go into the template or log key in K1. So that is the K1 we extracting the log key from the log file. And second one, the parameter is nothing, this particular template, that means deletion of something complete, the deletion of, and then you can start complete. It might be file 1 or file 2, file 3. That is the file ID, that is the parameter of this particular stream data. Okay, apart from that they are added t1 minus t0 into the parameter value vector. That is just because maybe they are executing, they need the how much delay is happening between the every log string. That also might be some representation of how fast your system is working, right? So that depends on the log file or your system process, not be applicable for every log file. So this is the section. You see, first was a raw text data, it is converted into structured data, that means divided into log key and parameter value vector. Like that, the two more they mentioned that it took 0.61 second. See, it took star second to deallocate network. That is the representation K2 log key. That is a K2 log key, and 0.61 is the parameter along with the time. The same is applying to the next one. So this type of unstructured log data we need to represent in a structured data. That means in a core table, like a table, that means into log key and parameter value. That is the first step. For that we are using a log parser. The standard of log parser they are using is so many log parser modules are available. the stated we're using for this paper is spell. So the spell is a parsing algorithm. Normally this parsing algorithm might have used some dictionary or some type of any type of analysis on top of that huge data, because normally the log files will be in huge size. It's very difficult to parse manually using some rules. And second thing, converting the parameter vector that we discussed about that thing is discussed in the table, the third column, that is the parameter vector. These two are the input to our deep learning model. Now second they're telling deep log architecture and overview. Okay, as it mentioned, we only need normal execution, normal files only we need. And they are telling that they are using three model. First model is for low key anomaly detection model, second one is parameter value anomaly detection model, and third one is workflow model. So they are using three deep learning model. Let's see how the figure is. See this figure, deep learning architecture. See, this is a training phase. Here log normal execution file is here, and using log parser it is parsed into key and parameter vector. See, key k1 k2 k3 and the parameter vectors, and they are given this key sequence. So key is a sequence, that's why LSTM is coming. Key into the anomaly detection model, log key anomaly detection model. And this parameter vector, the sequence of parameter vector, they are fed into parameter value anomaly detection, the second model. And then we have two models, and here on the right side in the detection stage you can see there is a new log entry, and again we are doing a same log parser into the log entry and dividing and into structured file. That means log key plus parameter vector. Log key is given into log key detector. Log key detector will tell once test log key is get, it will tell that if any anomaly they will find out and tell there is an anomaly. Like that, the parameter value vector is given into the parameter anomaly detection model. That is also telling that about the anomaly parameter. If any one of this model is detecting in the anomaly, we will feed this particular stream log message or particular that log sequence into workflow model. The workflow model will tell what type of error or what type of anomaly it is, that is doing some diagnosis. And apart from, if any of the false positive means it was normal, but our model is to detect as anomaly. If that happening, this model will do an online training that will pass into the model, and it will retrain with that false positive sample. This is the overall architecture. Sounds good, right? So this is the architecture, and then these all are mentioned in this paragraphs how it's working. As I said, treat model, this one threat model I'm not discussing, because it's saying something about some protection in your system file. Here it's a anomaly detection, how the anomaly detection execution path. See how they are given this unsupervised. If there is no label, how they are trained, right? That's a big question. See, look at here, K22 K. See, we are taking the log key file for log key deep learning detector. Key anomaly detector is the input data is the log sequence of keys. Though, so the sequence of that key has been taken from a log file, or might be it might be taken from a 60-second or 1 minute log data. Okay, so we need a sequence, right? From a single line of log message you are not able to get the log key sequence, so we need at least 10 or 10 50 15 log message. From that message you will get some sequence of key value. Suppose that key value is k22 and then k5 k11 k9 k11 k26 as mentioned in this dictionary. So first thing, we are approaching with a window. Here is mentioned window size h is 3. That means k22, k5 and k11 is the input, and the next element k9 is the target. So we are having the label, but the label is taken from the data itself, data sequence itself. It's predicting the next sequence element. Likewise, here in the second dictionary down this line k5, k11, k9. That means this window is slided to one right, right, just right. So the next predicting is k11. Again, sliding to one more right, k11, k9, k11 again. Then what will be the target? K20, k26. So this type of labeling is doing from the dataset. It's automatically we're taking. We don't need any manual labeling, right? So it's predicting the next key value. So how we'll do that? We are doing with the recurrent neural network, or we can do that with even n-gram model. N-gram is also doing the same method, predicting the next value by using the probabilistic distribution or co-occurrence matrix or some that kind of approaches they are using to predict the next value. So what is happening in the traditional n-gram model, language model? Because see, this is again a language model. This log file are telling about some patterns. We got the sequence in terms of log keys. Now we need to extract the sequence pattern, sequence order, all of this information to find out how the normal execution of the file. See, they are using LSTM approach simply because LSTM approach is using, because LSTM can handle a lengthy sequence. It will automatically memorize the required data or the required data points or sequence. It can handle lengthy sequence, and most of the time these log files, the very important sequence is the very recent sequence. We need the very recent sequence, might be the main factor for finding the prediction of next key value. So that all will do by the LSTM. That's mentioned in this figure. That is just a single LSTM cell. How that is this figure is dealing about how the LSTM is working. That LSTM, all LSTM block having some cell state and hidden state, the input, right? So 1 2 3 cell, that's all are hyperparameters that no need to explain. LSTM is different topic. See here mentioned. So actually we are doing a classification problem. The classification means number of classes is how many logs you are having. Suppose my log file having, I extracted 1000 log key, 1000 different unique log key. Then my classification algorithm having 1000 classes. So they are using the loss function categorical cross entropy as mentioned in this paragraph. See, one more important point didn't discuss, because we converted our unstructured data into log key, the sequence of key. But still, this log key is we need to convert into a number, right? The symbol conversion is encoding. We can encode 1, 2, 3, 4. K1 we can give it to 1, K2 2, like that 1, 2, 3 we can represent and give it into the model. But that is a good approach, but still they, in this paper they used one hot vector representation. That means if suppose I am having 1000 log key file, each key will be represented with a one hot vector of 1000 value. Only one value will be 1, all other value will be 0. That means a sparse matrix, big sparse matrix, that is one hot vector. So every log keys are representing in one hot vector. So we are finding the vector, one hot vector of next key. That is the representation, and we are doing the LSTM. See again, this is only using the log key. Log key will tell something, some order, about some order of your anomaly, but still some anomalies can happen from the variation in your parameter value. So they added one more model that will detect the parameter sequences. For that, these parameter vectors as input, they created one more LSTM model. See the parameter vector in this table, you can see that this is a vector, parameter vector. This parameter first row parameter having two elements, second element also having two elements, 0.61 at time, and third one is don't have any parameter, that didn't have any parameter. So parameter vector length can be vary. For some messages parameter might not be there. So for that, that kind of length and that kind of variable length can deal with LSTM. Again, it will predict the next vector. Same logic as in the log key. Suppose you are giving the sequence of first two parameter vector. By using that vector, it is predicting the third vector. The input at each time step is simply the parameter value vector from the time step. Output is the real value vector as a prediction for the next parameter vector. Correct? See, for this vector representation, they are using square laws, because this vector is not a might be a regression type of. We need to find out the next vector, right? It's not a class actually. So they used mean square laws to minimize the error. Okay. See, now you got two model. Uh, One is a low key model, and second one is a parameter model. So now a new test data is coming. You got a new set of prediction. Next to sequence is predicted. How you will understand there is anomaly or not? For that, they how what this paper they did, they having a validation set of validation files, and estimated the Gaussian distribution of that validation group, Gaussian distribution of that group's prediction, and if any deviation from that distribution's limit value, the confidence interval value, then it is an we are representing that as an anomaly. Okay, that error between prediction and the observed value within the high level of confidence interval in above distribution, then that parameter value or that low Q value will referred as abnormal. Okay, if that is in between the confidence interval, then it's normal. If it's above that confidence interval, then it is abnormal. There is distribution, the Gaussian distribution. You can understand this having a deviations and a deviation values. That value or distribution we are taking from the validation dataset. Next paragraph, they're telling online update of anomaly detection model that we mentioned before, because once any you are doing online prediction of a new log stream data, if you are predicting a false positive, that means a normal execution, if you are predicting as anomaly, that normal execution will that normal execution stream is taking, and then we are retraining the model, and will boosting the model's performance. That's also an advantage of this work system. See, workflow construction from multitask execution. See, third advantage of this system is that if you are finding as an anomaly, you will finding out the workflow model. That means diagnosis, applying a diagnosis on top of the anomaly detection. What is the goal of this workflow mentioned here? Log entries for different tasks in file and build. Okay, because this workflow's main goal is to separate the log entries, because log entries are might be happening from different system. Might be you are running 3 4 devices at a time, or might be running sequentially, no, serially. Then the log file, the type of log file is creating is not in the same pattern. Might be different task is completed. Suppose your one screen is one screen or some machine is running for finding out some creating any semiconductor process, wafer process, anything. Then that process log stream is different than the other devices. Might be that is other device might be checking the voltage variation. This type of devices will generate different type of log file. So need to separate that task from the log file based on the log key sequence. So log key separation is the next task in workflow construction, multitask execution. They're telling they're using the idea of small invariant mining to do this separation. Anyway, this figure might be easy. See in this A section an example of concurrency detection. See here 25 18 54. They're telling 25 18 54. The window size they are given taken it here is 3. That's why this 3 sequence, then the output will be 57. Okay. Again taking the 18 4 57, then the output will be 18 or 56. That means every time you are predicting the next log key value, you might having more than one suggestions. It is not like that only one key is probability is 1 and all others probability is 0. It's not like that. The model will give a suggestion depending on the probability. Suppose the model given a suggestion of 3 keys, your next key might be one of the 3. One's probability is 0.7, others probability is, second one's probability is 0.2, and the third one's probability is 0.1, like that. The total probability will be 1, right? So that is the probability. Using that highest probability we are taking, normally we are taking the log key. But sometimes it's not like that. It is exactly the next log key will should come. The train data might come might have some two more or three options of log keys. That is because of the concurrency of the system, because two devices can be running at the same time. So the log file can generate the systems process of the two devices. Okay, so the two devices streams concurrently might come into the log file. These all issues are there in this project. So they're telling that because we can find this concurrency by using this diagram, because if any concurrency is coming, see here after 57 there are two probability. It can be either come 18 or 56, right? Suppose we have high probability for 18, then after 18 it should come the 56, not any other key value. Then we can refer it as a concurrency. That's how we can detect the concurrency. This paper they're telling like that we need to detect the concurrency. That's a big challenge in this task. The common pattern is that the key with the highest probability in the prediction output will appear one after another. See, appear one after another. See here in this diagram, after 18 the probability of 56 is coming, either 18 or 56, then the 31. That is the sequence. And second challenge is that if the probability is not that much, then it can be a divergence point. Might be the task is finishing and new task is starting, right? Our goal is to find out the list of tasks, right? So here you see the second B, the example of new task detection, 25 18 4 54. See 18 54 57, the next one. And the third one is, you see, it was 24 and 26, two loci that they have probability, but it is not repeating one after other. That means Suppose you find a 24, you predict as 24, and the next one, as per the logic they're telling, it should be 26. It should, one after other should come, but it's not 26, it's 60. Like that in 26 also, after 26 it is 37. So that's how we can find out a new task is started in that sequence. Normally we have lot of sequence, right? There's a sequence of lot of log keys. In that sequence itself, here they are trying to clustering the sequence in terms of task. For that they are using the telling that this LSTM, using LSTM, by using this criteria they can differentiate. But important thing is that they need labeling for this model. Anyway, LSTM is going to find out this execution, right? We are anyway, after applying this rule into the model, we need to label for creating that model, right? We need labeling for creating that model. That is a big disadvantage. So what they are doing, they are going with density based clustering approach, like DB-scan. Density based clustering approach is the logic is they are using the co-occurrence matrix within the distance in this table. Co-occurrence matrix is something like from the time data set you will find out how the 2 pair or 3 pair n-gram or simple n-grams only repeating, and then from that distance they are telling, using some threshold they are telling, this is in this cluster, the DB-scan they are telling, right? uh, that kind of clustering they can use. The advantage of this clustering is this is unsupervised, because since our log file is very huge and big data, you're not able to do any labeling. So the second approach, the paper is going with, they executed the second approach, they mentioned this later. But this workflow detection is don't have any impact on how you are detecting the anomaly detection. This flow is useful after anomaly detection only. This is still, it's not applicable. I think this paper, even they discussed about in this paper, it is not that much applicable, because it's not robust that much. Very difficult to classify the sequence, particularly the log files key sequence, in terms of task. So once you created the model, there are a lot of parameters, hyperparameters are there. Here they are telling that the one of the two parameters, the trade-off parameter, is that the window size. How much should be your window? Because you are doing a windowing for you to take the sequence for input and labeling, right? Here they are telling that they are taking the three windows, three, might be it's not three, 3 to 10 they are telling in this paper can take. That means three continuous value sequence value and then predicting the fourth one if window is 3. And the second parameter is that g, the value of g means nothing, that means suppose you are predicting next key value, g will tell you up to next how many are the suggestions. You are predicting the next key value, suppose your g is 3, that means you are predicting the next key value, and the model will give you the three suggestions of key, might be key 20, key 13, key 44, three suggestions in terms of probability distribution. And you are taking, if any one of the three is coming as your original key, then it's normal execution. How this paper is detecting as anomaly, you will find out the next key using deep learning, and when the next key is coming as the same as predicted, then it is normal. If it is deviating, then it is abnormal. That is the logic. So these are the two main parameters in the deep learning model. See here, their prediction anomaly diagnosis using workflow in this prediction. They're telling 26, 37, 38. Okay, after 38 it should come 39. But what is predicted actually model is predicted 39, but what is actually happened? A 67th key happened is coming. Clearly this is an anomaly, right? This is the prediction correct path. That is the prediction method. They're telling that they addressed the major drawback of the major challenge in the log sequence, that is concurrency and of concurrency and multiple tasks. Both are they are addressed, but still it is in not that much improved method. See, these are the previous works they mentioned here. The execution path, normal execution, evaluation. For the evaluation, they evaluated with PCA method, invariant mining, TF-ID if they didn't do it for evaluation, because that is not resembling. They used this approach with HDFS log dataset, that is Hadoop based map reduced job dataset, and then OpenStack log dataset. These two log dataset they are used, and precision recall. See how, what is the parameter they are using. So G is 9, H is 10, L is 2, alpha is 64. G means nothing, that's how many key value suggestion you will get after prediction. H is the window size of the log sequence. L is the L is the number of LSTM cells, and alpha is the number of memory units in the LSTM. These are the parameters they got for best performance. And see the performance from OpenStack log evaluation. See, this black one is representing the Deeplog. Precision, recall, and F measure. Say precision is 0.95, recall is 0.96, F value is also 0.96. Good in OpenStack. Compared to PC and invariant that IM method, ngram. Compared to all these three methods, Deeplog is better. These are again for OpenStack 1 and OpenStack 2 dataset. And one more important parameter is parameter vector length. How many vector length you are taking for your parameter vector. That's also the value vectors for parameter vector. That's also having an impact in its accuracy, because we having two model for anomaly detection, right? See in this graph they use 25, 45. Both didn't detect the anomalies, but when they used 53 and 56 vector value for Loki 53 and Loki, they are able to detect the two anomalies happened here. Anomalies detecting using Gaussian distributions, the range value, that is confidence interval value. If it's above this confidence interval, then it is anomaly. This below row is detecting as anomaly. See one more impact they mentioned in this blog. What if I am not doing any online training? See, without online training and with online training. Without online training, with online training, there's a slight improvement from 0.8 to 0.88. Precision improved. Recall same. Recall didn't improve, right? F measure also improved. F measure from 0.9 to 0.93. So that's also very good. A slight impact in by doing online training. So here they mentioned that they used a density-based approach for task suppression. For density-based, they use the threshold of 0.85 to 0.9 between. They are using the threshold value. Now, related, this work was a lot of works is there. I'm not discussing about that PCA work, PCA engram. The conclusion they are telling about this LSTM based deep log network deep learning network is able to detect the anomalies without doing any labeling. Automatically is detecting the patterns. And second thing is important advantage is that if any pattern is not we don't want the anomaly labeling, right? That's the important advantage. And second advantage is they're telling that they are able to do a workflow diagnostic diagnosis for this anomaly. That's only in this for this paper. Last they mentioned the reference lot of papers. So this is about Deeplog, anomaly detection and diagnosis from system logs through deep learning. So log parser is important. Converting unstructured into structure is important. That is log parser. Which log parsing you are using, that will vary according to the log file and the character of the log files. Then LSTM network sequence. Third one they used workflow model. Workflow model is a bit complicated. They're telling density based approach is used to separate the task using some threshold, but still the concurrency in log file is an important challenge in this field. Okay.